Somewhere in the second or third slot up and leave it hanging out a bit, then clamp it. I guess I should have let you guys put it in there. So someone clamp it. It's your turn.
It's clamped.
Good, great. So now put your level on there this way. See how level it is transverse. Oh, actually I meant across the top here. It looks pretty good. The middle bubble pretty much in the middle. Okay, and then the other way. Actually, I guess we might need do we have a longer one? I guess we need a longer one to reach. Oh, you want to do that? Okay, good idea. How does that look?
Pretty good.
Okay, if it wasn't, then it would be time to loosen these guys depending on how we need to adjust it. And I have metal spacers that we put on. We loosen this, lift this up with like a crowbar and stick spacers underneath to lift it on each corner depending on what the needs are. But if it's good, that's great. We don't need to mess with it. So that's done. And the next thing, I think we're getting close to the end as far as maintenance. Let's see, why don't you loosen it and take that guy out, man? Do we have any loose, like 1/2 inch aggregate? Or 3/4 inch aggregate? Somewhere just like 10 pieces of aggregate?
Probably. I mean, these buckets are what Andrea says, so whatever they say on
Yeah,
that.
this looks good. It's all the way down. I think if you can go like this, Manny, where it sort of hits here, or it comes to the end, I think you've released it as much as it's going to go.
Okay.
So then this guy goes in, say the second or third one from the top, maybe the second slot from the top. Actually, there's even, I think there's one slot up here maybe, but that's fine.
Oh.
So that's fine. Yeah. Okay, I think that's the second slot. So, like I said, if we don't clamp it, it's really loud. Do you want me to run it for a second unclamped? Just so you see how loud it is? So if you hear it that loud, you know something's wrong, or you want to or no? Yes?
Sure. Why not?
Yeah. I'd love it.
Okay. Anyone want to clamp it again? Yeah, it looks good. Sometimes I just give it a little extra, but that's fine, Rick. That looks good. So now you found some aggregate, put it right in the middle here. What we're going to do is going to run it, and you optically observe the aggregate and make sure it's tumbling and rolling all over the place. If it's tumbling, if this is doing its job and shaking properly, the aggregate's tumbling and rolling and going all over the sieve. So of course I chose a small sieve. If it was the sieve for that aggregate, it would drop through. So because it's tumbling and rolling properly, if it has an opportunity to drop through, and the sieving process proceeds properly. You know. All right, so I'm going to turn it on, and all you do is just observe it for like 30 seconds or so, till you're sure it's getting shaken up really good. So see, one thing that's nice, I just observed, it's not collecting in one corner. It's going back and forth, back and forth. So it's sort of, that's good shaking function. If something was unbalanced, it would tend to go to one side and stay there. So I think this looks good. So I mean, for maintenance, I think we're done. Just to let you know, there's a plate here that's held on by 2 slotted screws, and here, near that bearing. So I think it may come in handy in some instances where you need to get in there and it's hard to get in from the side. You can take that plate off and maybe get down there to do something. I forget, I think one time I had to take the plate off or something, and it was handy knowing it was there, you know. So that's maintenance. The next step, the actual check, well actually the timer was part of the check, that they make sure the equipment's functioning properly, so we got that done. The next part is actually measuring out like a precise collection of aggregates. So many, starting with, let's see, probably, maybe starting with 1/2 inch. So let's say we got what, half, or what, 3/4, half, 3/8. And what, number 4 maybe, and number 8. And then number 16. Yeah, maybe 5 or 6 sizes of aggregate, maybe 6. Starting at maybe 1/2 inch. And I mean, if you guys want to do that, we can. It's a little time consuming. We could do it just so you see the result. We don't necessarily have to meet the standard. So you measure out this precise collection. You know what its mass is because you measured it out. And after it's done sieving, you see, did each sieve catch the correct amount of aggregate, its own aggregate? And you measure, so you have to get each sieve, you know, clean this out, clean one of these guys out, dump the sieve in there, whatever it collected after running it for 5 minutes, weigh it again. So it's a lot of detailed note taking. The total mass of the original sample, and then how much ends up in each sieve. And of course, when you measure out the original mass, the total, each aggregate, you're going to measure the mass of each aggregate. And so you'll know the, you know, aggregate by aggregate, those precise mass measurements. And when you dump it out in there and dump it into another thing and measure it, does that match up? How does that match up percentage-wise, percent error-wise, compared to what the original mass of that particular aggregate was? You know, say the 3/4 inch or whatever. And then you're allowed. We have the check procedure. I think you're allowed to be. It's pretty strict, but you're allowed to be like 0.5% off. It's pretty strict. So anyway, do you guys want to just go through the motions? To do the whole process, it's like 2 or 3 hours. We don't have to do that, but we go through the motions if you want, of making a collection of aggregates, letting it shake down, and then measure it, and then seeing each sieve how much collects. We don't even have to measure the masses. In your mind, you can imagine doing that, or we could, however you guys want to do it. It's up to you guys. I mean, if you want to measure the masses just for fun, so then when we're finally done and we're actually remeasuring just to see how close it is, just to see it, you know, we can do that. So leave it up to you. Do we have enough aggregates here to do all that? To have like 6 different aggregates? Or we could do it with 3 different aggregates. Do we have 3 different aggregates, Maggie?
Yeah,
okay.
I think so.
That are already separated out, or?
Yeah.
Okay, why don't we do that? So each one, there's a limit to how much you can put on this sieve. The instruction probably tells us, but let's say, I don't know, let's say 500 grams per sieve maybe. So we want to, let's see. Yeah, we want to get, do we have a bowl handy to put the aggregate in individually and measure each portion out? Yeah, say like a 1/2 kilogram per sieve. Or actually, actually, you know what you want is actually a lot of, what you want is a lot of pieces of aggregate because a kilogram of half inch may only be 2 or 3 or 4 chunks. That's not good. So you actually want about 30 pieces of aggregate per sieve. I think that's better. So 30, at least 30 pieces of each size, or a half. Okay, this came from the what? The 3/4 or half inch? Is that one? So you want to measure them out separately, right? At first, so you know how much of each one you have. Is that what that is? Okay. Whoop. So I don't know if you want to have a bowl on standby. So as you measure out each portion, you can just pour it in the bowl if you want. Here's here's one more little piece. Oh, and actually, this is a little bit on the delicate side. Well, you may know there's even finer sieve than this that's really delicate. You could actually bend it with your finger. You don't want to do that, so you want to be careful. You know. So is there one? So this will be